We're on problem 14. Problem 14. If the function f is defined by f of x is equal to x squared plus bx plus c, where b and c are positive constants, which of the following could be the graph of f? So b and c are positive. So what does that tell us? So a couple of things you immediately know. The x squared term, whatever is the coefficient of x squared, that tells us whether the parabola opens up or opens down. It opens up if the coefficient on the x term is positive, which it is. It's positive 1, right? So we know the graph is going to open up. It's not going to be a downward opening graph like that. So we know the graph is going to look like a U as opposed to, I don't know, an intersect. I don't know what this is, like an A without the line, whatever. So we know it's going to be a U. And what else do we know about it? What do we know about its y-intercept? Well, this is the y-intercept. When x is equal to 0, f of 0 is equal to what? These two terms are going to be 0, so f of 0 is equal to c. And so we know that the y-intercept is positive. So let's see if that alone allows us to solve the problem. So we know that the y-intercept is positive, so when f of 0 is going to intersect someplace on the positive y-axis. And we know that it's an upward opening graph. So the graph could look like this. Could look like that. It could also look like, well, this b term, I won't get too much into the intuition of the b term. So it actually, we actually know that it is shifted to the left. But based on just what I said, that it's opening upwards and that it has a positive y-intercept, this would have also been a legitimate graph. Anything that is opening upwards like a U, because this is a positive x squared here, and intersects the y-axis in the positive area would be a correct answer. And if you look at the choices, A opens down, that's not the right answer. B opens down, not the right answer. C intercepts the y-axis at 0, so that's not the right answer. D opens up, but it intersects the y-axis at the negative y. And then finally, E is very similar to what I drew in yellow, so that is our answer. E. Next problem. Almost finished with this section. Okay, they drew us a cube. Let me draw it big because this looks like it might involve some fancy. Let me draw the cube. So this is the front face. Whoops. Hit undo. All my time is spent drawing diagrams. Cube. Drawing a diagram, and then it goes back like that. Goes back like that. I should always draw the back first. It gets good enough. I think you get the point. And then there, it draws the dotted lines. Maybe I'll draw that later if I have to. Okay. So they tell us that this is point A, and that this right here is point B. They say the cube shown above has edges of length 2. So each of these sides are 2. Each of these sides are 2. 2, 2, 2, 2, and so on. And A and B are midpoints of the two edges. So A and B are midpoints. So this side is equal to this side. So if the whole side is equal to 2, and this A is the midpoint, then we know that this is 1, this is 1, this is 1, this is 1, right? Okay. What is the length of AB? So this is what they want us to figure out. They want us to figure out. I'm going to draw it in kind of a darker color. No, that's not a dark. Of that line. This is a pure visualization problem. And at first you're like, boy, that's it's 3 dimensions. It's crazy. What am I going to do? And what you're going to have to do is do the Pythagorean theorem twice. So what do we know? Well, we know everything we need to solve this problem. Let's see if we can do it. So let me draw that bottom surface. The bottom surface of the cube. So I'll ask you a question. Can we figure out, so let me draw a line along the bottom surface. Let's say that this line I'm drawing is along the bottom surface of the cube. So I'm going to draw this line That's along the bottom surface of the cube. And let me label this side like this. This is actually a really fun problem. I'll do this in yellow. So can we figure out what that magenta dotted line's length is? Well, sure. We know that first of all, that is a right triangle, the way I drew it, right? I can redraw it like this, where it's yellow, brown, and then dotted line magenta, right? All I did is, I kind of flipped it up so that you could see it. So what is that? We know that brown length, we know that's 1. We know the yellow length is what? It's 2, right? Because all the sides of the cube are 2. So we can use the Pythagorean theorem to figure out the magenta line. So it's the square, 1 squared plus 2 squared is equal to this side squared. So we can just take the square root of it. So that equals the square root of 5, right? 1 plus 4. Square root of 5 is this magenta line. So the magenta line is square root of 5. So now can we figure out that gray line that I drew at first? Well, sure, because now we have another right triangle. That gray line is just the hypotenuse of this right triangle. That's kind of, at an angle. So let me make sure you understand what I'm saying. If I were to flatten it out, I have this green side right here. I have this dotted line base. And then I have the gray line, which is the hypotenuse. Right? And just so you know what this point right here would be A, and then this point right here would be B. And do we know the sides? Yes, we do. We know this green line here is 1, so this side here is 1. I'm just redrawing it here. We know the magenta dotted line at the bottom, which I kind of switched colors a bit. But we just figured out that magenta bottom line is square root of 5. So now we can just use the Pythagorean theorem to figure out the length of this line. The length of this line squared is going to be equal to the square root of 5 squared plus 1 squared. So the hypotenuse squared is equal to this, so we can take the square root of that. So that equals the square root of, what's the square root of 5 squared? Well, it's just 5, right? Plus 1. So it's equal to the square root of 6. So this line is equal to the square root of 6. And that is choice D. We luckily have not made a mistake. Last problem. Problem 16. Let x, with this kind of oval looking thing around it, be defined as x squared minus x for all values of x. If a, so they're telling us that a is equal to a minus 2, what is the value of a? So what does this mean? A kind of with this oval. Well, that just means that a squared minus a, right? That maps to that, just like that. And what does a minus 2 map to? And I'm just bringing the equal sign down. A minus 2 maps to, every place where I see an x, I put an a minus 2 in there. So that equals a minus 2 squared minus a minus 2. And now we just keep solving. And most of the solving is on the right hand side. So let's see, that equals a squared minus 4a plus 4 minus a plus 2. So we get a squared minus a is equal to a squared minus 5a, right? 4a minus a plus 6. Can subtract a from both sides, a squared from both sides, right? Let me add 5a to both sides. So 5a, so you get 4a is equal to 6. Divide both sides by 4. You get a is equal to 6 over 4, which equals 1.5 or 3/2. And that is choice C. And we are done this section. I'll see you in the next practice test.